Hey everyone, we are going to start in about a minute. We are just waiting for everyone to join and then we'll start. Okay, cool. Hi everyone, are you guys able to hear me? Just drop a bit yes or no in the chat, everyone. Abhijit, you are having some doubt around Liskov substitution, is it? One second. Okay, so let's unmute Abhijit. Abhijit. Yep.
Yeah, hi Sangeet sir.
Yeah, Abhijit.
Am I audible?
Yeah.
Yeah. So I have a doubt in LSP.
Okay.
So generally, like what I understood that the child classes should be substitutable for the base class. Meaning, let's say B is the child class B and C, okay, of
Mhm.
A, and then wherever we had something like new B or new C,
Yeah.
we should ideally be able to put a new A without breaking the existing functionalities,
Yes,
right?
kind of, yeah.
Yeah, is the other way also true? Like, let's say it had something like in somewhere in the code you are using new A, right? uh,
Who is the
does
parent class? Who is the parent class?
Yes, A is the parent class.
Okay.
uh, so
You can
like
take a better example,
could
maybe to explain.
Yeah, so for example, let's say I mean, the common example of the square, rectangle,
Okay, yeah.
and
Yeah, let's take that.
shape.
Mhm.
Yeah. So let's say we had, so I mean, by LSP, all rectangle, I mean, is not a square, because let's say it can have in rectangle we might be setting the length and width, whereas in square it is square, I mean, it does not make sense to have that behavior, right?
Yes.
And if we somehow override, then in the method we have to again do, like wherever we are setting width, we are also setting that equals to the length, which might change the length or width, right?
Okay.
Whichever is coming later. So in here, I mean, wherever we were using new shape, for example, to get the area, we could replace it with this uh, new rectangle or new square, right? But my doubt is like, I'm not able to exactly think of a scenario, but let's say somewhere we were using new rectangle new shape
We're
class,
not able to get
basically.
one second. Let me share my screen. One second. I guess you're not able to explain properly the doubt. Can you see my shared screen?
Yes.
Okay. So see simple. First of all, let me like clarify. List of substitution. Like for example, if you have a shape class, from shape class you have circle, square, rectangle. This is the scenario that you are mentioning. Can I say that?
Yes. Yes.
What
Correct.
List of substitution principle says that objects of superclass like shape, right, shall be replaceable with the object of base subclasses,
Yes.
right? For example, like
Subclasses.
if you say, let's say there is some class A where you have a class property shape S. So maybe in the constructor of A, right? Maybe in the constructor of A, you should be able to do something like S is equals to new rectangle. Are you able to get this point?
Yes.
This is LSP, list of substitution principle.
Yes.
Now you are
Yeah.
saying, can we do a reverse of it? Like
Uh,
I have a rectangle R and I do R is equals to new shape. Is that what you are saying?
yes. Ideally, it will throw error compile time in
Yes.
this scenario, I think.
That's a basic Java behavior. Yeah.
Yes, but I mean, let's say the client class A, what it is doing, it is calling something like shape dot area. Area is defined in all the subclasses also, right?
They will
And
must be
it
overriding.
returns
They
the,
must be overriding.
yes, we are overriding it, correct.
Hmm.
So in this case, we are able to like instead of rectangle, square, or circle, I mean,
Hmm.
instead of shape,
We
we are
can
able
just
to
call
do
it
new
what you.
rectangle, new circle.
Yeah, we can just
But
call it what you. Yeah.
yes, but let's say the circle class also has a one more additional method called get diameter or something, right?
Makes sense. Yeah.
Uh, and obviously square and rectangle will not have it, right?
Yes.
So by LSP, ideally, I'm able to also say S is equals to new circle.
Yes. S
Sorry, new
equals to
rectangle here and
new circle, new
new
rectangle.
rectangle.
Yeah.
Yeah, let's keep new rectangle.
Okay.
And then, but if I do that, so ideally my S new, if I do what I understand from LSP, if I do new rectangle, new square, or new circle, it should be irrespective, right? It should not
Yes.
uh, throw any
Yes.
runtime error. But
Yes.
here, if I do, let's say I did new rectangle, and then
Mhm.
I just did rectangle dot get area, ideally.
Like
Is it expected? I mean, does LSP also wants me to achieve this? Because then my
no, no, but
confusion is
I didn't
that
get like no. One second, one second. I didn't get your point. Like you are saying that S is equals to new rectangle we did, and we are now trying to do S dot area. Is that correct?
S dot get diameter, S dot
Get
get
them.
diameter, which is a compile error, right?
Yeah. Yeah.
So is it also violating LSP or not? Because ideally rectangle and square will not have it, though, but circle will have it. And shape does not have that method defined. Uh,
Hmm.
but I mean, is it violating LSP or not? If
Okay.
it does, because my confusion is if it violates LSP,
It's not
then
violating
as
LSP.
a,
I understood what you're trying to say. Let me give you a far better example. So let's say there is a company like, for example, Mahindra. Okay. Mahindra manufactures a lot of cars. There is a car, let's say XUV 700. XUV 700. Then let's say there is one more car, XUV 400. And let's say there is one more car, XUV 300. Make sense? Now let's say
Yes.
XUV 700 and 300, as far as I know, are petrol cars. Okay. So you can have a method, get petrol quantity. Are you able to get this point?
Yes.
But as far as I know, as far as I remember, 400 is a electric car. So having a get petrol method here will not make any sense. Can I say that? And let's say if there is a base class car. If there is a base class car, now here we want to have a method get petrol, and here we want to have a method get battery. How much battery is used? Now, if you put the get petrol method in the car class, then you have to override it everywhere. Can I say that? If you have to override get petrol method everywhere, like you have to override get petrol in XUV 400 also, that doesn't make any sense because you will be eventually throwing an error only. Can I say that?
Yes, correct.
And overriding get battery in 300 and 700 doesn't make sense because here you will be throwing an exception.
Yes.
This is your scenario, right?
Yes, correct. Yes.
This has nothing to do with. Sorry, yeah, tell me.
So my scenario was I don't.
Because you said the same thing. Na? Circle has some method that doesn't exist in rectangle and square. And shape class,
Yes,
if
correct.
will expose that method, then rectangle and square will either override them. Right?
We'll have to, yes, correct. Yeah.
We'll have to in case it's an abstract class. If it's a normal class, then maybe it has its own implementation also. So if you call r.get diameter, it will call shapes get diameter. Are you able to get this point?
Yes.
Right? Same thing here. Let's say if this car is a concrete class, then if it should be having its own get battery method. So if XUV 700, you do not manually override, it will call the get battery of the super class. But if it's an abstract class or if it's an interface, then you are bounded to override it here. That's a problematic situation.
But it is possible for get petrol and get battery methods to exist independently in the derived classes, right? In XUV classes and not be present
Then
in
again,
the car
that's a
classes.
problem. If you do XUV 700 get petrol, XUV 300 get petrol, the implementation is going to be same. You will be having code repetition. Are you able to get this point?
Yes, it is a code repetition. Yes.
So this is a very classical.
But my confusion here is that. But then, what essentially what is the use of extending classes? Ideally, if I'm extending XUV classes, so I should be able to ideally have behaviors, certain extra behaviors than the car class itself.
Right? The question that you are saying, like, what is the use of it? It's saying that कि इस दुनिया में साइकिल थी तो कार क्यों लेकर आए? पेट्रोल भी बचता था, एनवायरनमेंट भी बचता था, कार की जरूरत ही क्या थी? पेट्रोल में वो साइकिल में इंजन लगा देते. It's like that. ये कहना कि why do you have extension of class doesn't make sense because there will be scenarios where you need inheritance exactly. But if you will see in my LLD lectures, I have specifically said that inheritance technically causes a lot of problems, right? That's why the solid principle comes into the picture. And this problem that you're mentioning is a classical problem. It's a pretty classical problem in order to solve, right? I can give you some hints. So there is a dedicated design pattern called as strategy pattern. Read about it. Okay, but apart from the fact that we will go individually read about it, I can also tell you. Now, in this case, what should happen is your car class, your individual car class interface, whatever you are making it, right? Let's say you have an interface. You should have a dedicated, this should have other car properties like, for example, tire, engine, so on and so forth. Now, because having petrol or having battery is something not every car will possess. What you can have is, you can have other interfaces, petrol car or battery car. And then what should happen is XUV7 and the methods get petrol and get battery, these two methods. This method get petrol. One second, what happened to my pencil? this method get petrol and get battery. This should not reside in the car interface. It should not be present here. Get petrol method should be present in the petrol car interface. Get battery method should be present in the battery car interface. And XUV 700 will implement the car interface and petrol interface. XUV 300
but it more like ISP, right?
Yeah, it's gonna move it towards the, I would say, implementation of ISP. But you will see that, let's say during runtime, if you have to make a choice, like if you, like for example, maybe now XUV 700 can have sometimes petrols, sometime for example electric also. Like for example, there is a car named as what do you say, Nexon, right? There is a Nexon car. Now Nexon is petrol as well as electric, right? So strategy pattern will help you in solving that kind of a scenario, where during runtime, when you are initializing Nexon, you want to decide whether you want to have a petrol Nexon or you want to have a electric Nexon. So in that case, what you will do is you will keep a engine strategy property. There will be an engine strategy property that you can keep in the corresponding Nexon class. And when you will be initializing, this engine strategy will be taking an implementation of either petrol car or battery car. So strategy pattern will be an extended version of your original problem, but ideally your problem can be solved using ISP. It has nothing to do with LSP. I don't think it has anything to do with LSP.
Got it. Okay.
Makes sense? It's a pretty classical problem. It's a pretty classical problem.
Yeah.
And I guess we have discussed, like if you will go to ISP, we have discussed it as well.
Yeah, I mean, I was in the other batch as well when, I mean, these strategy patterns and solid principles were discussed. Somehow, like while revising, I got confused.
Because I can show you. One second. If you see strategy the problem that you said can be solved by ISP, but strategy pattern like takes it to one more level plus. If you see strategy pattern. Okay. Of course, internet examples will be very bad, but we can still live with it. So what you do is you define, let's say, an interface strategy, right? You have, let's say for our case, this will be engine strategy interface. Okay. And maybe we will be having a get engine type function. Then we'll be having a petrol engine, which will be implementing engine strategy. And here we will return the engine type as petrol. And then we'll be having a electric engine strategy, which will be implementing the engine strategy class. And here we'll be returning for example, what do you say? Electric car engine type. And maybe if you want one more, maybe hydrogen car, I'm not sure. I don't have that thing. Okay. Now, what you will do is you will be having this context class. This context class will be, for example, can be your, let's say, XUV 700 class. Okay. Now, XUV 700 will be implementing, let's say, your car class. So it will get all the, extending your car class or implementing car interface, whatever you want to do there, do that. But it will be having a engine strategy composition. It will be having an engine strategy composition. And during the creation of the XUV 700 object, I will pass what engine strategy do I want to get. Are you able to get this point?
Yes, yes.
In fact, rest of the people, are you able to understand what discussion we are having here? Rest of the people, are you guys able to understand what is the discussion we are having here? Like it can be useful for a lot of people, and it will help us to implement or discuss the strategy pattern as well. So, for example, I'll just very quickly try to code this in front of you guys, strategy pattern. Okay. So, for example, now, just in case if everybody is not able, was not able to recall what was the scenario, let's say there are 3 types of cars, XUV 700, XUV 400, XUV 300. XUV 700 and 300 are electric cars. So when you do get car or get petrol data, kind of like that, okay, in that case, they are going to give you petrol data. But here XUV 400 is an electric car. So there is no point of having petrol related data in XUV 400. So it should be having data related to battery. But now 700 and 400 has nothing to do with battery. So the question that is coming up ahead in front of us is that the properties related to petrol and the properties related to battery, should they reside in the parent car class or car interface, or where should they reside? Are you guys able to understand what is the problem that we are facing in front of us? Okay, so how can you solve it? How can you solve it? So for example, let's say there is a basic car class that we are going to have. I generally do not take examples like car and everything, but because the discussion came up immediately, so I was not prepared with an example already, but this is still a relatively nicer example. Okay, and let's say this car class is going to have, for example, a few public, let's say private properties, private int, what do you say, max speed, private boolean, has airbag, so on and so forth. Maybe some more private like properties altogether. Okay. Yes, Agarwal. Shubham Agarwal. Okay. Now the thing is, should this car class have the get petrol or get battery methods? No, this car class should not have that, right? Because not every car is going to be petrol. Not every car will be having battery, and those cars which will be petrol will be throwing an exception in the get battery method, and those cars which will be having battery will be throwing exception for the get petrol method. So you are technically just enforcing inheritance altogether. So better thing to do could be you make an interface petrol engine. You make an interface petrol engine, and this interface is going to actually have a method public string get petrol. Okay, and we are going to make one more interface battery engine. This will be having a method public string get battery. Okay, and now let's say if we have a XUV 700 class, we have a class XUV 700. This XUV 700 is going to extend from the car class because it is going to have basic car properties. But what it is going to do is it is going to implement the petrol engine interface. That means here we are going to override the public string get petrol method. Right. Here will be having some implementation system dot out dot println some petrol. Okay. And what's the error? What's the error? Oh, what is the error? Am I missing something?
Yeah, we want to return from this.
Oh, return. Oh, sorry, my bad. Return. Okay. And similar to this, let's say there is another class XUV 300. Okay. This is also going to extend the car class and implement the petrol engine interface. And this will also be having a same implementation here. Okay, cool. And then comes XUV 400. XUV 400 is also a car, so it will be extending from a car, but it will be implementing the battery engine interface. Battery engine interface. And this time we are going to override the get battery method and we'll say some battery. Are you able to get this point? So here in this implementation, now you can see the car class is clean. It doesn't have any related property to get battery and get petrol because now individual cars can actually handle that. Individual cars can actually handle that. But do you see one more problem? Yes. Now the problem is this get petrol method in XUV 400 and XUV 700. This is again common. Can I say that? Everybody. Isn't it? This get petrol method is kind of like common in both of the classes. And if this is a common implementation by any chance, this is going to lead to code repetition. Code repetition means invitation to bugs. In that case, we have to refactor it. Yes or no? Here comes, so now currently, as of now, we have implemented the interface segregation principle. But here comes strategy pattern into the picture. What we can actually do is, we can have another interface and we call it as engine strategy. We have engine strategy. See, we have an engine strategy. Okay. And then what you can have is this engine strategy method. This engine strategy method is going to have, for example, let's say something like public string get engine type. Okay, let's have one method here. Let public engine get engine type. And now what we are going to have is, let's say we are going to have a concrete class. Okay. Petrol engine strategy. Okay. Petrol engine strategy. This petrol engine strategy is going to implement engine strategy. That means it needs to override. It needs to override the get engine type. So here the engine type is going to be petrol. And one more class we'll make. What do you say? Battery engine strategy. This is going to also implement engine strategy. And we are going to say this here. And we are going to return battery. And now what I can do is, instead of making our XUV 300 and XUV 700 implement from petrol engine, instead of doing something like this, how about I keep a property public engine strategy engine. Okay, public engine strategy engine. And inside the constructor, public XUV 700, inside the constructor of XUV 700, what we are going to expect is, we are going to expect an object of petrol engine strategy as strategy. And we'll say this dot engine is equals to strategy. Okay. And similarly, let's copy this thing here. Go to 300. Paste it here. This should be the constructor of XUV 300. And now we do not need petrol engine here as well. Are you guys able to get this point? Okay, cool. Now what you can do is, your engine strategy can expose one more method. Public string get fuel. Get fuel. Okay. Public string get fuel. Okay. And what you can do is, your petrol engine strategy can actually override your get fuel method. Your get fuel method, can I say that? Okay. It can override your get fuel method. Can you guys see this? And here, maybe you are going to return, let's say 30 liters. Somehow we are computing the petrol fuel of the car. I'm just leaving the implementation altogether, right? So we have a get fuel method here that we have overridden. Okay. And then I can have one method, public string get petrol. Okay. Public string get petrol. And technically not here. Now, same thing we should technically override in battery engine strategy as well. Let's say 30%. Okay, something like this. And now in XUV 700, what you can do is, wherever you want in some method, like public string get info. Let's say we have a new method, public string get info. What you can do is, you can call this dot engine dot get fuel. Now, if your engine is a petrol engine, it will automatically take a petrol engine, right? And give you the fuel according to the petrol engine. And now the best part is, there can be a car like Nexon, which can have like some Nexons can be petrol, some Nexons can be what? Your battery operated as well. So now you do not need to implement on either petrol engine, or you do not need to implement your battery engine. Whatever is your strategy, whatever is your engine strategy, that engine strategy will just take as a parameter, right? So in fact, here we should technically not do petrol engine strategy. We should just say engine strategy. My bad. This was my bad. We should just say engine strategy. And here as well, we should just say engine strategy. Now, whatever engine strategy you want to give, let's say if you give a petrol engine strategy, now because this is a parent class, you can pass based on Liskov substitution principle, you can pass the object of the child class. Can I say that? Everyone? Yes or no? This is your strategy pattern, right? So this helps in these kind of cases where during runtime also you might want to change the strategy of the operation altogether, right? That strategy pattern in front of you. It's a very, very easy pattern to be like. This is one of the easiest patterns. This is one of the most widely used patterns in interviews. Like in my Flipkart interview as well, the question that was asked was solvable by strategy pattern. So yeah, strategy pattern is kind of cool. Make sense, everyone? Any questions? I know this was like apart from this, but I thought a design pattern discussion will complete. Any questions, guys? All good? And technically, you can do one more thing. Like now, if you want to have a get petrol kind of a method, right? If let's say you want to have a get petrol kind of a method, right? So what you can actually do is you can just make this one as a get petrol method, which will be internally calling this dot engine dot get fuel. As simple as that. Copy and paste it here as well. Instead of saying get info, let's call it as get petrol. And now same thing you can do for this XUV 400 as well. Now you don't need to do this, and you can, sorry, cancel. I'll copy the implementation from here, paste the strategy here, call it XUV 400. And this time, instead of saying get petrol, you can say get battery. See, now the implementations are clean, right? Okay. And if you want to make sure, if now you want to make sure that XUV 400 has to override the get battery method, like there should be a get battery method, because maybe now now one question can come to your head, right? That sir, maybe somebody doesn't implement this get petrol method, how we will have the access to the get fuel method? That's your simple ISP, right? You just go here and you say implements battery engine. The moment it implements battery engine, you can just return this. Can I say that? And if you want to make sure that 700 always implements the petrol engine. Right, because this question can come to your head, right? That maybe somebody willingly doesn't override this method, then what? Then no problem. ISP is already there. So strategy pattern clubbed with ISP is going to solve our problem. And this is now super cool. Can I say that? Everybody. So design patterns are for your aid, guys. Whenever you see situations where you realize that there is some kind of code duplicacy, where you realize there is some kind of redundancy, something is not right with the design quality of the code, it is a smelly code, that is a good time to actually look for some kind of design patterns coming up ahead. Make sense? I hope this discussion was useful. Coming back, I'll just push this code in case you guys want it. Okay. So you can read some articles on strategy pattern. That should be great. I can just by taking one more minute, just by taking one more minute, I can actually, in fact, show you. You can see this was the machine coding question for my Flipkart round. And if you see this part, bonus requirement, can you see? Patient can also cancel an appointment in which those slots become available for someone else to book. Different ranking strategy. Use rating of doctor as a strategy to display a list of available doctors for a given specialization. Can you see? Now you can have different ranking strategies. Now you want to rank the doctors. Are you able to get this point? Okay. Now you can see the slot should be displayed in a ranked fashion. Default ranking should be rank by start time, but we should be able to plug in more strategies like doctor rating, etc. So how the UI should look, or how the system should look like? System should be showing, let's say this is a hospital management system. So you want to book a slot. So by default, the slot should be arranged in the form of start time of the slot. But if the user wants, they can actually plug in, or maybe they can use different ordering, like doctor's rating, in order to arrange the slot. That whatever doctor is having the highest rating, maybe we have to arrange the slot based on that particular doctor's data. Are you guys able to get this point? Do you smell strategy pattern coming up here? Because now during the runtime, based on user selection, you have to figure out what should be the ordering. If during runtime for based on user selection, you have to change the strategy, it's strategy pattern. Make sense? If you guys don't have it, I'll just give you this doc. This was for my machine coding round. In case you guys don't have it, I'll share. Okay, now you have it. But yeah. Cool. Coming back. You can say kind of, but I would say, like, because you pass, like you're saying that whatever callback you pass, based on that callback, the execution works. That's the crux that you want to say, right, Abhijit? So we are not passing an object, right? You're passing a callback. It's more or less functional programming rather than any modified strategy pattern, I would say. It's more or less like a functional programming thing. Like JavaScript also does this. Yeah, in a more declarative way. Yeah, you can say that. Okay, cool. Coming back. So in the last class, we started our discussion around the high-level design. We were talking about the high-level design of our Uber application. Remember? Everyone? Okay. Now let's start talking about it, that at least on a high-level architecture, how things should look like. Whenever we actually build any kind of application, it is generally necessary to actually have some idea around the high-level design of that particular application so that we can get some context, what to do, what not to do. Okay. Now, there is going to be some set of clients, right? For our Uber app, there will be a web app client for probably admins. There will be a driver app. There is going to be a driver app. And then there is going to be a rider app. There is going to be a rider app. Okay, cool. Now, ideally, what should happen is that anybody, let's say driver or rider, if they have to do anything with our application, we need to make sure that they are authenticated. We need to make sure that they are a legitimate user on our system who are actually trying to operate on some particular thing. Now, interestingly, you can see that if we have to do authentication, we can have a common mechanism of authentication for both of them, maybe OTP authentication or login, email password based authentication, some authentication. Now, ideally, what should happen is there should be a dedicated microservice that we can call as the auth service. This auth service is going to be a dedicated Spring Boot project that is just going to be responsible for authentication of users. All the users who are actually authenticated, like if they want to first of all sign up, that logic should also go through auth service. If they want to actually log in, that logic should also go through the auth service. So any kind of logic in that case should be ideally going through the authentication service altogether, right? So ideally both the drivers, right? Both the driver and the riders should be communicating to the auth service. Now, don't you think there is an interesting use case? Like this is one microservices. Now we'll be having some more microservices. Do you want your client side to directly communicate to your microservices? Because how you have divided your microservices is your internal logic. You don't want to probably expose it to the client side. Why? Because this is exposing too much information on the client side, first thing. Second thing, there can be a problematic scenario that maybe somebody tries to do a DDoS attack on one of our services. Maybe the service will go down, right? Maybe they will get extra information about some particular data of that particular service, some config variable, something. The more exposure you will give on the client side, the more chances of your system being hacked is going to be there. So ideally, what should be there? There should not be a direct communication between your microservices and your client side. Ideally, there should be a middle end. Like if you will go and work in big tech, you will realize that this is your front end, this is your back end, and then you have something like a middle end. In your middle end, you can have something like an API gateway. This API gateway you can manually set up, or there are dedicated Spring Boot packages that can help you. Like there is something called a Spring Cloud Gateway that can actually help us this API gateway. Now, right, what this API gateway is going to do is all the requests are actually going to come on this API gateway. So the only thing that the clients are going to be known about is going to be this middle end architecture. Now, inside this API gateway, you can do a lot of things. You can do maybe rate limiting. Okay. Maybe on this API gateway, you want to do rate limiting. You can do that logic here. Okay. Maybe you want to do some conversion of objects, right? That let's say client is actually, let's say the web app and the, let's say now, for example, there can be some common applications in web app and the mobile apps also. For example, if the rider wants to get the invoice of their previous rides, they can get the invoice from the app also and from the web app also. Now just think about it. Web app might be sending some other type of information. Rider app might be sending some other type of information, but we should be writing one backend to cater every kind of an invoice request, right? So maybe you can write converters here. API gateway can maybe contain your converter logic as well. that whatever are your incoming set of requests, you convert those requests in a common format and then send that format up ahead. So this kind of a conversion logic can also come into the picture, right? And so on. Multiple things you can actually do. And this actually makes sure that your overall architecture is more secure as well. This enhances the overall security as well. And now it will be the responsibility of API gateway to then forward the request to the corresponding microservices, right? So now API gateway, if you want to have an authentication request, is going to forward the request to the authentication service altogether. And generally, what you will find is that sometimes for catering one particular request, you might want to interact with multiple microservices. For example, there is one microservice M2, there is another microservice M3, right? For that case, ideally, what should happen is there is one more available layer. There is one more available layer called as the orchestrator or the orchestration layer. What is the responsibility of the orchestration layer? Orchestration layer is going to be responsible for one thing, that if there are multiple microservice interaction that is going to happen, like let's say you want to request one microservice, then get the data from that, then request another microservice, get data from that, then parallelly request two microservices and individually get the data from that. This kind of an orchestration, this kind of a management, if you have to do between multiple microservices for a request, then for that you have a different layer called as an orchestration layer. This will be a separate, for example, a Java project or a Python project, whatever you want to keep. For our simplicity, like just to make sure that we are keeping things simple, what we can actually do is we can actually club our API gateway and orchestration layer. Otherwise, for a small application, as I mentioned, we want to first go to a MVP situation, right? For a small application, we might have to do a lot of things. That might be unnecessary for us, right? So what we can do is we can club both of these together, right? We can club both of these together and make one individual service. Altogether, right? That is something that we are going to do. But if you see production level use cases, you will find orchestration layer or orchestration service different, this gateway, or you can say middle end different, and then remaining microservice interaction actually happens. Are you guys able to get this point? Drop a quick yes or no in the chat. First of all, like this much here. Do you understand the need of each and every individual component? Why we are having that? Like, I was never aware, like when I was in college, I was not aware about what is an orchestration layer. I generally used to do one thing. I used to like make a React front end, connect to a Node backend or Rails backend or Java backend, whatever. Like Java, though I didn't start in college, but Node backend or Rails backend. Then I realized that if there are multiple microservices, front end is not going to be responsible for managing all of the requests. Ashish says confused with orchestration layer. Ashish, just think about it. Let's say you want to book a ride. If you want to book a ride, there are multiple steps. First step, you first of all want to make sure the user is authenticated. So authentication request will come up. Then you are going to raise a booking request in some booking microservice. This booking service is going to actually somehow communicate with the rider app. When a rider is going to confirm the request, then this booking service is going to come back and get the data, and this data will be sent back to the rider app. Who is going to be responsible for these cross connections where one request goes to one service, comes back, then that data is sent to another service, comes back, and so on? Is client side going to be responsible for this? No, because if that's the case, then you have to implement this logic 3 times. Second, a lot of internal logic will be exposed on the client side, security issues. So for that reason, you generally have a different microservice called as the orchestrator. Are you able to get this point? Like we had an orchestrator for JPA, we had an orchestrator for LinkedIn enterprise provisioning, so on and so forth. If you go and work with Flip, like I've had discussion with Ria as well. Like if you work with Flipkart's, what do you say? Retail as a service team, RAS team, retail as a service, they have this orchestration layer as well. Like I can set up this orchestration in maybe Node Express.js or maybe Spring Boot. It is going to be a server in itself, Kaustubh. But for our simplicity, we are going to club both of these, probably. Got it? Or maybe we can make separate also, doesn't matter much. Means if our client has to make multiple requests and has to handle the response as well, we had orchestration layer which will connect to our microservice and cater the need. Yes, that's correct. Okay, cool. Now, apart from authentication service, there should be an individual service that is going to be responsible for booking, like booking and rides. And why I'm adding these kind of boxes? These layers means that these services are horizontally scalable. These services are horizontally scalable. Okay, so we should have a ride booking service. This is going to be an individual microservice altogether, right? Is this for security? This is for security. This is for scalability. This is for better maintainability of the code. Why scalability? Because something like Uber is very complex. Here, though, we are making 2-3 microservices, but actually Uber is like a humongous project. Managing cross communication between microservices can be very, very problematic. For that reason, you have orchestrated. Like I can give you example of JPA. So should I show my phone? Okay, let me show my phone. Notification बंद कर देता हूँ 2 मिनट के लिए. तो मैं तुम्हें दिखाता हूँ कि कब कब क्या क्या होता है. Like the moment you open a screen, what all things actually happen. I'll show you. This will give you a context about why orchestration might be important. So, for example, okay, not this. ठीक है, जैसे this is some guy, this is some XYZ guy. Okay, most of you guys must have seen this screen. Most of you guys must have seen this screen on JPA, right? Have you guys seen this screen on JPA? No. Okay, 1 second. Oh, my camera is off. I didn't realize. Have you guys seen this screen on JPA? Okay. Now, what happens for loading this screen is extremely complex. Why? So, if you carefully see, there are 2 names that generally pop up on the screen. There are generally 2 names that pop up on this screen. Can you see paying to whom and banking name? Can I say that? Can I say that? Okay. So, there is something called as, can I tell? Okay, so there is some RPC. There is some RPC. What that RPC does is, it actually is responsible for collecting the send options. Send options as in like, what are the user options or the payer and payee option that we want to send. For example, who we want to pay, the phone number, the VPA, all of that. Now, for example, phone number of the other user, maybe we have in our database, because assuming that the other user is also a JPA user. But banking name of the user, maybe that's not in our database. For getting the banking name, what do you have to do is, you have to go to the bank servers. Actual bank servers you have to go and get the banking name from there. Are you able to get this point? And then, so there is one service that gives us the user details. One service that is responsible for communicating with the banks. So that gives us the banking details. Now, one service is to fetch the, now once the user details are fetched, now we also need to fetch the details of payment methods, that what all bank accounts have been added on JPA. We need to, because on this same screen, as far as I know, the moment you add the amount, immediately the moment you add the amount, you get all of the bank accounts that you have registered with JPA. So you have to fetch the details of those bank accounts also. Now, handling of bank accounts was a different microservice altogether. So you can see a lot of interactions is there, right? If let's say you scan a QR, If you scan a QR, that's a separate RPC. What that QR scanning does is it fetches the merchant details, that whatever merchant you want to actually pay to. To fetch the merchant details, if the details are not in JPA servers, we actually interacted with NPCA servers. So this is first task. Along with that, parallelly, I am the payer, right? So my payment details need to be fetched. That what all bank accounts I already have added on JPA. So that detail also need to be fetched. Then there was a risk service that used to actually check whether this is a risky transaction or a non-risky transaction or not, and so on. A lot of things were there. So for just opening this one screen which has not even done the payment, so many RPCs used to communicate with all together each other, right? So how all of this communication between multiple RPCs will go? Do you think we will write this logic on the Flutter client side? No, we have a dedicated orchestrator. Make sense? So that's the reasoning of having orchestrators. Just think about it. Now I have to get merchant details also, and I have to get the payer details also. 2 tasks are already there. Then I have to check risk also. 3 tasks, right? Maybe if you have registered UPI wallet, then I have to get the wallet balance and everything also. A lot of things are there. So this layer is added to do async tasks in order to decrease the latency. These tasks can be synchronous or asynchronous, anything. Sagrika, for example, maybe to communicate to the second microservice, you need the data from the first microservice. Then you will do synchronous communication. Are you able to get this point? Sagrika? Any more questions, guys? Okay, cool. Let's come back. So in that case, we can actually club both of these. Now, how exactly ride booking and everything should work? Now, once the driver or let's say rider raises a request, we are going to first authenticate the rider. We are going to first authenticate the rider that yes, the rider is a authenticated user of our application. And then what we are going to do is we are going to initiate a brand new booking request. We are going to initiate a brand new booking request. Now, when we initiate a brand new booking request, so there will be maybe a new entry of booking in a pending state that we will technically prepare. Immediately, what we have to do is inside this maybe ride booking service, or maybe you can have a separate microservice altogether. For simplicity, let's take it for now in the ride booking service. What we will do is we will try to fetch the nearby drivers. Okay. So let's say, or maybe this task is given to another microservice. For now, I'm drawing a new microservice, but during implementation, maybe we can take a call whether we want to have a different microservice or not. Okay, so this is a driver finding service. This service is responsible for just one simple thing, that is find the drivers maybe in a 2-kilometer radius or a 5-kilometer radius. Once this, so what this ride booking service is going to do is this ride booking service is going to communicate with this driver finding service. What driver finding service will do is driver finding service is going to be responsible for a few things. That is, first of all, it will keep the track of the latest driver location. Okay, it will keep the track of latest driver location. And based on that, this ride booking service is going to give it a latitude and a longitude of the rider. It will try to find maybe a 10 or 15, some set of drivers from a 2-kilometer or a 5-kilometer range or something. And then what it is going to do is it is going to actually send a notification. It is going to send a notification to all the drivers which were nearby that particular location, right? Meanwhile, what will happen to the user is the user raised the request. Now the booking is in process. User will get a response, the rider will get a response that we are trying to find you a brand new rider. And this process can take 5 minutes, 10 minutes. So we can't just keep them loading, right? So we give them a nice screen and show them that, okay, we are trying to find your driver. You can sit back tight and relax. Okay. Now, this ride booking service gave the latitude and the longitude of the rider to the driver finding service. This driver finding service will apply some geolocation, I would say algorithm or something, right? This is what it will apply. I'll talk about it. It will apply something, and then it will find a bunch of riders in a location range of 2 kilometers, 5 kilometers or something. And then it is going to notify all of those drivers. Now, notification can work in two ways. Maybe the driver has not opened the Uber app. Maybe the driver has not opened the Uber app. In that case, you have to send a push notification. That push notification you can send by FCM. What is FCM? Firebase Cloud Messaging. So if you want to send, let's say, I'm assuming most of our drivers have Android apps. Let's maybe for a use case, assume that most of the drivers have Android apps. So to send notification on Android, there is a Android service called as FCM, Firebase Cloud Messaging, right? You can just trigger a brand new message to a set of users, and it will actually notify those users. Okay. But to test this thing, we need to have an Android app and everything. So we are not going to consider this case for our implementation. The other case would be that the driver has actually opened the app. If the driver has actually opened the app, in that case, what we can actually do is we can maintain a communication between the driver and this driver finding service. What we can do is we can have a communication between this driver and the driver finding service, right? And how this communication is going to happen? First of all, when the driver will open the app, we are going to first of all authenticate the driver that yes, it's a legitimate driver. And then what we can actually do is we can set up a socket connection, a WebSocket connection, between this driver and this driver finding service, because we have authenticated the driver, right? So what we can do is we can set up a WebSocket connection. What's the benefit of a WebSocket connection? WebSocket is a two-way duplex connection. At any point of time, if this app wants to send some information to our server, it can immediately send without any issue. And even if the server wants to send directly the app any information, it can also send that. We don't have to bother about exactly kind of like a polling, like when the client will send me a request, then only I will send a response. We don't have to bother about that. Okay. This is one way to set up a WebSocket connection. Or what you can have is you can have server side sent events. There is something called as SSE, server sent events, in which when the server will be having some data to communicate to the driver, it will then only send it without having a WebSocket connection or duplex connection altogether. One important piece of information, WebSocket is also a TCP connection only. Okay, cool. If we have a WebSocket connection, then we can use that connection to update the driver location also. Maybe every 3 seconds, we can send a new request to our WebSocket pipeline that, okay, I have sent you a brand new location because my car is constantly moving. Because this driver finding service can be responsible for checking the current location of the ride as well. Because just think about it. Every ride will be associated with one passenger and one rider. So if inside our database, we have the live location of the driver, that is something that we can consider as the live location of the overall ride. And to just make sure that security concern is maintained, if you have an Android app or a iOS app for the rider, you can check the GPS location of the rider as well. And if there is a deviation of a certain limit between the GPS location of the rider and the live GPS location or latitude longitude of the driver, then that means there is some security concern. You can raise something on that. But again, we don't have an Android app or an iOS app in that case. Okay. So either you can set up a WebSocket or you can do polling from the driver app to the driver finding service in order to update the location. And you can do server side sent events from this driver finding service to the corresponding driver app altogether. How many of you guys are able to get this point? Drop a quick yes or no in the chat. No, you can say not in the range. You can have a constant connection with all the drivers altogether. Like you have X number of drivers. Let's say if you consider something like Ola, probably Ola has what, 1 million drivers or 5 million drivers. Maybe you can have, and how many of them are active? Maybe you can assume that at any point of time we are running at 40% capacity. So whenever any driver has opened the Ola app, that's when we can set up a WebSocket connection. Now, WebSocket has their own set of issues as well. Can anybody tell me what is the set of issues with WebSockets? It will create security issues since it's not passing through API gateway. No, Rachel. We already will be authenticating our driver app, right? So driver will be only coming from an authenticated source only, right? And we can put individual rate limiting on each individual service also in case we expect some issue from there. Okay. So we can implement anything. We can maybe implement a WebSocket connection, or we can implement polling from driver side and server side sent events from the driver finding service. Anything should work. WebSockets have their own individual issues that you have to maintain a persistent TCP connection between multiple parties, and how many persistent connections can be actually activated is limited on every machine. So in that case, if you have too many drivers, what will happen is you have to scale this service a lot horizontally in order to maintain all of those drivers altogether. Are you guys able to get this point? Okay. So I want you guys to take this task, think about it. Should we do long polling and server side sent events, or should we do WebSockets for our project? What do you think should be a good strategy? Again, in high level design, I believe everybody knows there is nothing wrong, nothing right. It's about what all perspective you think about. That being said, now we have this driver finding service to get the live location of the driver. Apart from that, get the driver from a nearby location, let's say 2-kilometer range for a particular latitude, longitude. And then whatever driver has selected or accepts the ride, that is going to be notified to the driver finding service. What this driver finding service is going to do, it is going to notify this ride booking service. It is going to notify this ride booking service. And then this ride booking service will notify this to the rider app that, hey, we have a brand new rider allocated to your booking. These are your booking details. And you can now calculate the booking details based on the driver current location. You can actually calculate how much time the rider is going to take, driver is going to take to reach to your location. And because driver will be moving, so driver will be keep on sending its location to the driver finding service. Driver finding service will be populating that live location to the ride booking service, because maybe the data storage for ride booking service will be also putting the ETA of the driver. You can calculate it, maybe some Google Maps API, or somehow you can maybe calculate it. Probably there should be some Google Maps API where if you give 2 latitude, longitude, based on the shortest path, it can calculate what you are having. We'll not go to that much amount of complexity, right? But what we can actually do is, if the driver sends a live location, then we will update this live location data with the ride booking service, calculate the ETA, and then update that to the rider app. Now, again, the same thing happens. This is again an asynchronous communication, right? Either we have to send this data through server side sent events, or we might have to set up a WebSocket connection between the rider app and the booking app. Are you able to get this point? The ride booking service. So WebSocket connection, if we are going with the WebSocket approach, we need WebSocket connection for both
rider and driver. Are you able to get this point? Now, in order to maintain this, instead of maintaining individual WebSocket pipeline between driver app and driver finding service and WebSocket connection between rider app and the ride booking service, we can have an individual WebSocket manager. Okay. What will happen is, if driver has to communicate anything to the driver finding service, we are going to use this WebSocket manager to do this communication here. And if this driver finding service has to update anything to a particular driver, we are going to make an API call to this WebSocket manager. And then this WebSocket manager has the pipeline open to drivers as well as the pipeline open to the riders. It is going to correspondingly send the data to the driver or the rider, whatever, like in the information packet, in the HTTP object, we can actually send whether this data is for the driver or this data is for the rider, what is the data, and then you can just send the data altogether. So this can be a WebSocket manager, right? Now you can individually scale this WebSocket manager, because now all this only responsibility here is to maintain the WebSocket connections and send the data. Now your driver app is now no more directly linked with the driver finding service. There is again a layer in between. So security enhances. Apart from that, there can be, this can also be horizontally scaled, right? This can also be horizontally scaled, right? Now, how do we know which particular application server is handling which driver? Maybe there are 3 servers running for this WebSocket manager. How do we know whether the server number 1 has our driver detail or server number 2 has our driver detail? How do we know that? In order to maintain that, what we can do is we can have a Redis cache layer. We can have a Redis cache layer. Inside this cache, what we can maintain is that which driver ID is connected to which particular server, I would say instance, server 1, server 2, server 3. So let's say driver D1 is on server 1, driver D2 is on server 3, driver D3 is also on server 3. This kind of a key value mapping we can store inside the Redis server. Now, whenever our driver finding service or ride booking service has to send anything to a driver or a rider, we will check, okay, which server, which socket manager server instance to communicate. We'll get that socket instance and then we'll send the corresponding data there. Okay. If one of the server instance will go down, all the WebSocket connection will drop. In that case, we can expect that the driver will be reconnecting to our app. So once they reconnect, a brand new socket connection will be up, right? So there can be different strategies that you can maintain for maintaining the connection between the driver and the rider. So this is an individual microservice that is only responsible for WebSocket connections, which will be having a, let's say, a Redis global cache that we can just communicate and get the data from, right? Apart from this, auth service, ride booking service, driver finding service, all of them can actually communicate to databases, right? DB. This DB instance we can actually keep, because now ride booking service is a booking mechanism. That means we can have transactional data. What if two drivers select the same ride, right? That there can be concurrency issues. That means for maintaining the booking related data, definitely we need what? We need a RDBMS. Okay. Auth service, if we are already having RDBMS for ride booking service, auth service can also be maintained in a RDBMS, no problem altogether there. For this driver finding service, this is interesting. And this I'm going to park for some time. That what type of database driver finding service is going to communicate. There is something called as geospatial databases that I will talk about later, how they actually work. There is a data structure called as quad tree and everything that internally it uses. But there are different databases which actually gives us the capability of searching in a kilometer radius based on latitude and longitude of user data. Different databases are there. MongoDB supports it. Postgres supports it, right? There are other databases apart from these as well that support geospatial data. But before that, you need to understand how any geospatial data actually works, because our Earth is what? A 3D sphere. And how do we actually manage that 3D sphere based latitude, longitude? So what we do is we map that 3D sphere into a 2D surface. and then do something there. But I'm going to park that discussion because we already have a lot of things to question about. So let's keep this still a question mark, that what kind of a database interaction we need for the driver finding service. Is this point making sense, guys? Is this point making sense? Now, do you understand how exactly the overall architecture is actually working? Anybody with any questions? There might be few more things that we might update in the longer run, right? Because like I want you guys to think about a few more things. There can be some bottlenecks that maybe we are currently avoiding and can come inside our architecture. So we have to think about it, right? That how we are going to handle those kind of bottlenecks. Anybody can think of any bottleneck anywhere? Okay, I'll keep that with you. I'll keep that with you guys. I'll keep that with you guys. That how exactly you are going to figure out these bottlenecks and everything. Okay. But yeah, this is going to be more or less the architecture. Now, because in this project we have to interact with WebSockets, this is going to be an interesting journey. Is there anybody who has worked with WebSockets in Spring Boot? Anybody? Rachel says yes. Rachel, what kind of interaction have you done? Oh, no. Okay. So there is a highly likely chance that you might not have interacted with WebSockets with Spring Boot. It can be an opinionated comment that I'm going to make, although it doesn't matter for us, but Spring Boot doesn't have the best architecture to, I would say, communicate with WebSockets. There are a lot of things that you might have never heard about, and there is no simple package that makes our life easy. So of course, we are going to see how to set up these kind of WebSocket servers for Spring Boot. But if by any chance this would have been a Node project, the easiest service to prepare would have been this WebSocket manager. Because Node.js has some really pretty simple libraries, including something called as socket.io, which makes the life overall easy. Like, but we will not be coding it in that way, because a lot of you guys might not be having context around Node, and we want to make sure that we learn things about Spring. But setting up sockets in Spring is a hassle in itself. But of course, we will be doing it the hard way. But there's something called as socket.io. Right. What socket.io does is it's a pretty simple WebSocket connection platform that you can actually get. Okay. And you can see it has pretty good JS connections altogether. If you have to set up WebSocket connection with Spring Boot, WebSocket in Spring Boot, then you can check this. So what you have to do is, not this. Yeah, sorry. Let's go forward. There is something called as sock.js and Stomp. So Stomp is a protocol. It's a WebSocket protocol that defines the type of message, text and binary, and content can be undefined initially. So we have to integrate the Stomp protocol along with sock.js in order to make our WebSocket go alive. So we'll see how much part we are going to handle with WebSockets. Maybe we can use server-side event for something. We'll see. But I believe you are getting my point. Make sense, guys? Like setting up it is going to be a good task, to be very honest. Like you have to register the Stomp endpoint, right? And then you have to see what client library, like the client then also need to use something called as sock.js client. So you can read about sock.js. You can see sock.js versus WebSocket. Okay. Sock.js is an open source real-time messaging library with both front-end and back-end component that sets out to emulate the WebSocket API. Created at a time before WebSocket was widely supported in web browser, Sock.js automatically falls back to older HTTP techniques such as HTTP long polling in situations where WebSocket is unavailable. Right. So Sock.js uses WebSocket, but in case the architecture doesn't support WebSocket due to any reason, it's going to fall back to HTTP long polling automatically. But yeah, it's going to be an interesting job to do. Make sense? Anybody having any questions regarding the overall high-level design architecture that we discussed? Any question that you feel, okay, this particular component doesn't make sense to you? Why we are introducing the Redis cache? Why we need to have a WebSocket manager? What is the requirement of that? So on and so forth. Long polling and WebSocket difference. Long polling is like periodic request response lifecycle. Simple HTTP request response lifecycle, but in a periodic fashion. That your client is going to poll after some time that, hey, do you have a response for me? Hey, do you have a response for me? Hey, do you have a response for me? In WebSocket, you don't have to do that. WebSocket is a pipeline-based connection. Pipeline-based connection means at any point of time, if servers want to send some data, client doesn't need to ask for that data. Client will just get that data immediately. It's kind of like a pipeline. For example, let's say there is a water pipeline. There is no water on both the ends. Suddenly the water comes on the other end. You are going to immediately get that, right? It will flow automatically through the pipeline. Are you able to get this point? WebSocket is a pipeline-based architecture. Okay. Why we are preferring WebSockets? I'm not saying we are preferring. I'm saying the solution that I have proposed is based on WebSockets. Do you see any problems with WebSocket? I want you guys to actually explore WebSockets. Do you see any problems with WebSockets that due to which you might want to change things to long polling? Because there is a thing that locations might not update every second, because there are, like most of the countries, let's say if you think about a service like Ola is only in probably tier 1 cities. Tier 1 cities means during peak traffic, the cars probably are not going to move by 500 meters, probably in a minute also. Like if you go in Bangalore, your car barely moves 1 kilometer in 5 minutes. Okay. Are you able to get this point? So maintaining a WebSocket connection where the car is not even moving probably or moving very slow can be too much for our servers. But if you see something like Uber is a global app. If you go to Australia, if you go to Dubai, if you go to America, like at least in Dubai, in 1 minute, the car can probably travel 10 kilometers also. Like I have seen cars running, like I've also sat in a few cars which were running around 30 to 40 kilometers per hour, as far as I remember. Like you can check, and that's a humongous amount of speed. You can check Dubai highway speed limit. You can see 120, 142 they have as the limit. People have supercars that actually crosses that speed. So if even if I go by this, that this one was the highway that I was in, Abu Dhabi one, 140 kilometers per hour. So if you are able to go 140 kilometers per hour, then in 1 minute, how many kilometers you can travel? Think about it. Let's try to calculate. Okay. If in 60 minutes, sorry, if in 60 minutes, we are able to go 140 kilometers, 140 kilometer per hour is what? Around 60 minutes, right? So in 1 minute, you can go 140 by 60 kilometer. That's what? 7 by 2, 7, 14, 2, 3. 7 by 3. What's 7 by 3? 7 by 3. That's 2.333. That's when, if you go by the speed limit, I've seen cars immediately crossing like 200 as well very easily. If some car is going with 200 speed, in 60 minutes, they goes 200. So in 1 minute, they can go 200 by 60, 20 by 6, 20 by 6 is what? 3.3 kilometers. So not 10 kilometers, but yeah, 3 kilometer, 4 kilometer, they can immediately jump in a minute. So that's where maybe a socket connection can help. But then also socket connection will be having a problem. What problem that they will be having? Because now they will be, so I'm not sure if you know how networking works in mobiles and everything, that if you cross a particular area, you hop on to the next tower. Have you seen the communication towers? So one tower is for one pod. If you cross that pod, you have to communicate to the next nearest tower. This sometimes that's why it happens that if you are traveling from one place to another, immediately your sound stops and then immediately it comes. That's because there's a signal jump. Okay. Sometimes the latency is too less that we don't realize. Earlier, the latency used to be too high when 2G, 3G was something. Latency used to be too high. So in that case, like there will be a lot of hopping. So maybe the user has to, the internet has to be super fast in that case. But of course, countries like Dubai has tremendously fast internet as well. So it depends whether you want to have a WebSocket connection or whether you want to have a server sentiment. Maybe depends on your business use case. Maybe your business use case is for something like India, where traffic jam is a very common thing, right? So maybe setting up all of these WebSocket connection might be an overkill. And you can actually check. So let's check. How many maximum WebSocket connection can a server handle? You can see by default, a single server can handle 65,536 socket connection. Okay, this is not WebSocket connection. This is socket connection. I want WebSocket connection. So is WebSocket connection equal to socket connection? Let's check. Yeah, I guess every port, but no, I don't think this is right. Is it right? It may be right. I'm not sure, but you can check. Or we can just GPT this information. GPT is the new way of searching most of the things for me. Stop 1 second. Let's modify the question. WebSocket connection can a server from handle? Server hardware, network bandwidth, complexity of the data, this, powerful CPUs, this. Okay. I want a count, bro. You can see it depends on how many open file descriptors you have. You can read about what is file descriptor. For every TCP connection that you have a dedicated file descriptor that gets set up. Okay. Tens of thousands of WebSocket. Still some number. Approx. We can also ask this to Gemini. Okay, so you can see if you have a 4 CPU core, 16 GB RAM, you might expect to easily handle 5,000 to 10,000 WebSocket connection very efficiently. Okay, for optimized environment with high-end hardware, you can even communicate to probably a lakh WebSocket connections. So depends, like, and you can check how many drivers Ola has. So as of 2020, Ola has 2.5 million driver partner across India. So 2.5 million is 25 lakh drivers. If at any point of time, okay, so this one says 1.5. What's the right data, man? Let's take an average. Let's take 2 million. So it's approximately what? 20 lakh drivers. If let's say one machine is able to handle 1 lakh connections, or let's say, let's go optimistic. One machine is able to handle, let's say, 10,000 connections. How many machines you will need? Ideally, like if you want to just do the calculations. So you have overall 2,000, 20,000, 2 lakh, 20 lakh drivers. And let's say one machine is able to maintain 10,000 connection. You need 200 machines, 200 server machines. That's not a very high ask, to be very honest. And then these are 2 million overall drivers. How many of them are actually active? If you assume that maybe 50% are active, that's also a very big number, because most of the time what drivers do is they register on Uber also, Ola also. They ride multiple apps and everything. So if I assume 50% of them are there, you need 100 machines altogether, right? So you can do this calculation and then you can see how much server cost you are going to burn. They make money also, but yeah. Are you able to see? So like your architecture is going to depend on what do you need instead of what do you want. Are you able to get this point? Any questions, guys? All good? Okay. So let's come back. So we have a basic high-level design architecture. That's also not basic. There are a lot of moving variables. And once we start building individual services, we'll talk about architecture for individual services as well. Right. But to maintain any service, now we have to do database interaction. And that's the next interesting part that we are going to talk about. How many of you guys have worked with any kind of database interaction with Spring Boot? So traffic will automatically handle by WebSocket, or do we need to take care of that ourselves? Traffic as in like car not moving in the traffic. Network traffic. Like depends, like if there is a lot of network traffic on your server side, then you will be scaling horizontally a lot of servers, right? To manage that network traffic. You have to set up the architecture accordingly. You won't be able to test. Yeah, so you need to load balance that so that individual request, like because one WebSocket connection will be persisting between a driver app and your app and your WebSocket server here, right? So once you have that, then you need maybe a Redis connection to remember which driver is associated to which web server and so on. Got it? A case where driver doesn't have internet, is it a significant case to look for now for MVP? No. If a driver doesn't have internet, how can they ride a cab? Because to get a ride, they need to be connected to the internet. To see the location, they need to be connected to the internet. Are you able to get this point? Internet is mandatory, right? Yeah, internet outage for 10 minutes can be there. In that case, what will happen is you will not get the driver moving details. So nowadays, Uber has this information, right? That Uber actually shows you that your car is not moving for 10 minutes. Is everything all right or not? So Uber is going to actually send a request to the customer that you are not moving. Is everything okay or not? So you can have triggers, like let's say, or you can have cron jobs that can run every 10 minutes and see which all driver location has not updated. Like you can keep a updated at property in the driver location table, and you can see which all drivers currently have a ride going on, but their location has not been updated for like last 10 minutes. In that case, things are not going in the right way. So you can write a dedicated cron job. Cron job is kind of like a scheduled job. You can read about cron job, guys. Make sense? So now you can see there are a lot of moving pieces, but when you design MVP, you have to make sure that you have an app up and running. And once scale comes up and once everything comes up, then you start actually understanding how things actually work. For example, like there's no point of integrating FCM as of now, like Firebase messaging server, cloud messaging service, whatever it is, because we don't have a Android app as of now, right? No point of banging our head there. Are you able to get this point? Any more questions, guys? Whether we'll be using REST API apart from WebSockets? Yes, Rachel. Majority of the communication between the services is going to be from REST API. Like this service communication with authentication service, authenticating is all going to happen with REST API. We're going to skip some part of the WebSocket, like where maybe we want to show long polling, we can do that also using REST API. A lot of things we'll be implementing through REST API only, because already implementing WebSocket is kind of like problematic. Okay, so let's do one thing. We need to start with database interaction also. Like we'll do a quick introduction only, that there is something called as Spring Data, JPA, Hibernate, ORMs and everything. We'll start our discussion on that. Let's have a quick break. Let's have a 15 or 18-minute break. And post break, we'll come back and we'll have just a light discussion on database interaction in Spring Boot. We'll not do any coding, don't worry. Okay, then we'll be having a light discussion on that. Okay, let's have a quick break and then we'll come back. Okay, is everyone back? Is everyone back, guys? Okay, cool. Let's resume our discussion. Okay. I hope you guys are feeling a bit fresh now. Okay. So anybody has worked with any kind of database interaction with Spring Boot, or any other Java framework like maybe Micronaut or something else? App is Drop Wizard or something? Anyone? Guys, anybody has worked on this ever? Any kind of interaction, like database interaction you might have done with Spring Boot, something? No? As far as I remember, some people were having Spring Boot in their jobs already, right? No. Personal project. Anand said I had. What technologies you used to have in your company, Anand? Same question to Satvik. What technologies you used to have? Spring Data JPA. Okay, let's start talking about it. So let's come in. So now database interaction is a pretty important part in backend technologies. Now, if you see in the world of Java, right? Java supports database interaction from quite some time. It's nothing new for the overall Java ecosystem to actually have support of database interaction altogether, right? So for a quite good amount of time, Java and Java related technologies, any enterprise framework, used to depend on something called as JDBC. What is JDBC? JDBC stands for Java Database Connectivity. Java Database Connectivity. Now, what JDBC actually supported, right? JDBC was kind of like a low-level set of API or set of functions using which you can directly interact with databases. Helps in direct DB interaction. Okay. Direct DB interaction used to help. Okay. We can directly use JDBC to execute queries to a DB, to execute queries to a particular database, right? Here we used to write queries were written as strings. Okay. Here what happens is that we write queries as strings and then pass those strings in JDBC functions and then pass those in functions exposed by JDBC, right? Okay. So this was the old way of actually doing stuff. Let me show you some code example. We can very easily find some simple code example that can show you how JDBC connection you can actually set up. So if I go here, you can search for setup a basic JDBC connection for MySQL. Now, before it loads, JDBC used to support a lot of connection drivers. What is connection driver? Now, JDBC exposes a bunch of functions to the user. These function internally uses these connection drivers. What are these connection drivers? Connection driver used to have the logic based on which whatever database you select, maybe MySQL, MariaDB, PostgreSQL, whatever you have, how to connect to that database server, that logic was actually present in these connection drivers. Okay. So let me actually show you. You can see Java database connectivity, JDBC with MySQL. Okay. So what do you need is, you need the driver class. So there is something called as com.mysql.jdbc.driver. Okay. So every database has exposed their own set of drivers. Okay. And those drivers can actually integrate with JDBC very easily in order to communicate, in order to pursue the communication of any kind of a JDBC, I would say, interaction altogether. I hope this much point is making sense to everyone. Drop a quick yes or no in the chat, guys. Is this point making sense? Any questions? Any questions around what is a driver or what is something, anything specific? Okay. So now if you continue seeing here, what you are actually doing is, you need to have access to this connection string. So every database actually exposes a connection string that you can actually use in order to connect to that particular database. Okay. And then what you have to all do is, you can see, you can use driver manager dot get connection. You can see there is a method called as driver manager dot get connection. Okay. Right. These also, what are these driver programs? These drivers can be a Java code altogether that has been written by the corresponding databases. Okay. And here you can see what you have is, you have to set up a connection. You pass the connection string, you pass the user, you pass the password. And what it will give you is a connection object. It will give you a brand new connection object altogether. Okay, cool. And now using this connection object, you can actually make queries, right? You can actually make queries. You can see, for example, you can create a statement, connection.create statement object. In this statement object, you actually write your query. Select star from something. Let's say select star from employee. It will actually give you a result set. It will actually give you a result set. And you can see all of this result set, statement, connection object, everything is coming from java.sql.star. Can you see? This is coming from java.sql.star. Okay. So you can see it gives you a result set, and result set gives you kind of like a stream based API that if, let's say, result set dot next exists, like the next data pointer exists, you can say result set dot get int 0.1, 0.2, 0.3, like this is like columns of your database. Like, so every row is going to be one result set instance, and then you can get the first column, second column, and third column. And at last, what you can do is you can close the connection altogether, right? This is how traditional Java, I would say, database interaction used to generally actually happen. How many of you guys are able to get this point? Drop a quick yes or no in the chat. Do you want me to actually execute this code? Maybe do you want me to try this also? Or just theoretically you understand, like whatever you guys say. Akash says yes, Abhijit says no. What about rest of the people? Rahul says understood. No, like, so I should not try, right? Okay, cool. Maybe you guys can try. It should be pretty simple. You can just set up a basic Gradle project and then add a MySQL driver, and then just use connection strings, simple connection string to connect to your database, and then execute raw queries. Make sense? Okay, cool. Now, this is old school. This is old school. Why I'm saying old school is that we have now a new way to actually connect to all of this. Can anybody tell me what's the kind of like a relatively newer way to connect to all of this? Hibernate. I guess Hibernate comes later in the picture. ORM also kind of like comes slightly later in the picture. Okay, let's see. Now, what JDBC actually gave us? JDBC had access to the connection drivers, also called as driver managers. Driver managers. Okay, they used to give us access to the connection pool of the corresponding database, right? It used to give us access to execute raw queries altogether that used to help us in most of the stuff. Then, of course, in Java, everything is object oriented. We are more oriented towards getting object and classes based interaction. So later, there was a new introduction to the overall database architecture in Java, which actually, which actually led to the introduction of something called as JPA. This is not Spring Data JPA that I'm talking about. I'm just talking about JPA. What does JPA stands for? Java Persistence API. Okay. What is Java Persistence API? JPA is a specification for accessing, persisting, and managing data between Java objects and relational tables. Okay, so JPA actually was the first introduction, right? That was actually done. You can say JPA was kind of a layer of abstraction. It was a abstraction layer on top of JDBC. Internally, it recommends, or internally it uses JDBC only. But what it does is it actually puts a kind of like what do you say, abstraction layer on top of JDBC, right? And what kind of abstraction? Now, instead of writing raw SQL queries in JDBC, you were writing raw SQL queries. Due to the introduction of JPA, instead of writing SQL query directly, we used to write classes and objects, and methods to interact with the database. And internally, these methods were calling raw queries only because they are made on top of JDBC. But as a developer, now you do not have to like care a lot about directly writing raw queries, directly managing connections, right? It gave us a specification to actually interact with the database using the direct Java classes. So you can maintain entities in the form of Java classes, and those entities can have manager that can help you to create, read, update, delete on those corresponding tables. How many of you guys are able to get this point? Drop a quick yes or no in the chat. Okay, so you can actually see if I show you JPA when was it launched? I'm not sure if it is having a date. You can see the final release date of JPA 1.0 was May 2006, relatively after quite some time. Are you able to get this point? Okay. Now, you can see JPA was launched around 11 May 2006. And if you see when JDBC was launched, when was it launched? You can see it's pretty old, 1997. Okay. So JPA was a new interaction coming into the picture. Now, as I mentioned, JPA was a specification. Now, what does this specification include? Does it include concrete classes? Now, first question that should come to your head is that, Was JPA including concrete classes? No. JPA is not a set of concrete classes. Instead, JPA is a set of interfaces and annotations. These are a set of interfaces and annotation made on top of JDBC, right? Okay. And they describe these annotations and everything, describe how you can actually map Java objects to the database table, right? Now, there were a lot of interfaces like entity manager factory, queries, a lot of interfaces were there. And apart from that, there were a lot of annotations like entity, table, ID, column. All of these were actually there, right? And then they gave a specification that we are exposing a set of interfaces and we are exposing a set of annotations. You can use this annotation and provide implementation of these interfaces to connect to the JDBC architecture. That's where ORMs came to a life. What is ORM? ORMs are object relational mapper. Now, ORMs were actually based on JPA only, but it's just that ORM contains concrete classes. What are some of the examples of ORMs? Hibernate is one of the ORMs. Hibernate is one of the ORMs. Open JPA is one of the ORMs, right? Eclipse Link is one of the ORM, and so on. These are ORMs which used to implement all the interfaces and their corresponding methods with concrete classes and actually use these annotation in order to do the task. Right? So you can say that JPA was a set of interfaces that were then implemented by these ORMs in order to provide concrete classes. The best part was that all of these ORMs were having a consistent set of APIs because they were actually overriding the same set of JPA interface methods. That's where ORM came into the picture. So you can say JPA was actually promoting the use case of Java classes and objects instead of raw queries. But they didn't give the raw, or I would say they didn't give the concrete implementation. Concrete implementation came through ORM. ORMs were the classes that actually overrided the methods of corresponding JPA altogether, right? So you can actually see, you can search about JPA interfaces and you can search about JPA annotations. Let's see. So if you go, not Spring Data, this, you can see JPA architecture. You can see JPA had a bunch of interfaces, entity manager factory, entity transaction. You can see what was entity manager factory. This is a factory class of entity manager. It creates and manages multiple entity manager instances. What is entity manager? It is an interface. It manages the persistent object on object. It works like a factory for the query instance. Then you can see there was entity. Entity are persistence objects. Stores are stored as records in the database. Can you see? Right? And if you see annotations, JPA annotations, then there were a lot of JPA annotation like @entity, @table, @ID, and so on. And nowadays also in Spring Boot projects, you use these annotations. A lot of people think that these annotations are coming from Spring Boot. No, these annotations are originally coming from JPA. Okay. This is something that you have to always keep in mind. I believe that JPA, due to JPA, only entity models were used. Yeah, you can say that. They were giving kind of like the signatures for them. And then came into the picture Hibernate or like other ORMs. Hibernate ORM. Okay, you can see Hibernate ORM. If you actually see the architecture of Hibernate, one second, let me show you. So let me show you the architecture of Spring Data JPA. I'll talk about Spring Data JPA also. Okay. Here, you can see Hibernate dbutils, these kind of ORMs sit on top of JPA. JPA sit on top of JDBC. JDBC sit on top of RDBMS. Okay, you can see JPA provider. Hibernate has its own native API, and it is also an implementation of Java Persistence API. So Hibernate will provide the implementation for Java Persistence API so that it can be easily integrated with any GPA supporting environment. You can see. So that's where ORM came into the picture. So you can say ORM gave the actual live concrete classes that you can use in order to connect to the database and query the database, or so on and so forth. Now, you know that Spring and Spring Boot is what? Opinionated. They actually provide you a set of predefined or pre-existing constants or pre-existing configurations that are generally very good for most of the projects, right? That's where another library came into the picture, which used to sit on top of Hibernate. You can see that is called as Spring Data JPA. You can see Spring Data JPA. What is Spring Data JPA? It's a part of the larger Spring Data family. Makes it easy to implement JPA-based repositories. Can you see? It makes it easier to build Spring-powered applications that use data access technologies. Okay. Spring Data JPA aims to significantly improve implementation of data access layer by reducing the effort to the amount that's actually needed. So now what was happening was ORM used to give us a set of classes and everything, a set of functions and everything that we can use in order to interact with the internal architecture of the RDBMS. Now on the top of ORM came Spring Data JPA. Spring Data JPA, again coming from the Spring family, was giving a basic set of configuration, some basic set of functions, right? So what Spring Data JPA is again working on the concept is that because most of the applications are going to use definitely a certain set of functions. So what Spring Data JPA will do is it will automatically expose those functions for you. You do not have to care about it. Are you able to get this point? So let me actually show you. So for example, if you actually see here, you can see what all you have to do is you just have to create an interface that extends something called as CRUD repository. What is CRUD repository? This is coming from Spring framework.data.repository. Okay. And then it will automatically give you a certain set of CRUD methods to create the entities, to delete the entity, to read the entity, to update the entity. If apart from the default set of CRUD functions, you want something specific, all you have to do is just define the signature of the interface methods. All of this we are going to actually see working in the code, but all you have to do is just define the interface methods. For example, find by last name. Now Spring Data JPA will automatically, whenever you are going to call find by last name, you do not need to give the implementation of that. Spring Data JPA will automatically form its implementation that here you want to find by last name. So what it will do select star from customer where last name is equals to your given last name. You can say find by ID, select star from customer where ID is equals to this provided ID. So you can see, for example, if I go here, you can in fact even Google default set of functions provided by Spring Data JPA. We'll see all of this in action in code, but let's see. You can see there is something called a JPA repositories that actually promotes a lot of repository pattern coming up. Okay. And you can see again here, you just have to extend your user repository with, let's say, instead of CRUD repository, you can just introduce it with repository. It will give you some other set of methods. And now you can write a method like find by email address and last name. Now, this function automatically says that you want to find a user by its email address and last name. Now, you do not have to implement how to execute this query. You do not, at any point of time, you do not have to say select star from user where email address is equals to this and last name is equals to this. No, you do not have to write that implementation. Spring Data JPA will automatically give you that implementation just by having this interface defined. You do not need to implement this interface altogether anywhere. Okay, you can see it will automatically form this query altogether. And you can see if you want to form all of these, like for example, if you say something like this, find by first name starting with, it will automatically prepare a like query. If you do, let's say between, find by start date between, it will automatically do a between query. Are you able to get this point? So it will automatically actually show you everything. It will automatically do everything for you. That's the best part about Spring Data JPA. So you can see you started from writing raw queries in JDBC. Then actually you came up to something like JPA, which gave an opportunity to ORM technologies like Hibernate to introduce class-based interactions for RDBMS so that you do not have to write raw queries, and instead you can write class and object-based code in order to interact with the database. And then on the top of it comes Spring Data JPA, which saw that most of the time you have to probably use a certain set of function always. So why you are going to take the hassle of using the ORM, creating the ORM object, calling methods in the ORM object, so on and so forth. Spring Data JPA says that just define what method you want. I will automatically prepare the implementation for you. That's what is actually happening behind the scenes here. How many of you guys are able to get this point? Some are predefined and some you can actually write find by this, and it will automatically get it for you. We'll see all of these in action. If you guys want, I can show you a quick demo as well. Should we see a quick demo, guys? Do you want to see a quick demo? I'll show you how to write custom queries. There are two ways. You can write raw SQL queries also. You can write a Hibernate queries also. Like I'll show you. Guys, there is provision of writing raw queries also. It's not like now you cannot write raw queries. When there is a very complex interaction, then these ORMs generally tend to fail. In that case, you have to write raw query. Like for example, if you have to do a 12 table join, then raw queries are going to help you. You didn't understand the difference between JPA and ORM. JPA are the set of interfaces. ORM are the classes that implement those interfaces. Paul Shovik. Are you able to get my point? Why there is a need of interface? So that we can have consistent APIs. Yeah, calling तो तुम खुद करोगे पवन, but उसकी implementation तुम्हें देखने की जरूरत नहीं है. Let's see an example, guys. एक छोटा सा example देखते हैं, चलो. I hope I have MySQL connection with me. First of all, let me check, guys, if I have MySQL ready. मैं अपना MySQL का ना password बार-बार भूल जाता हूँ. Okay, cool. चल रहा है अभी तो. Okay. Okay. So now let's see a few things in action. Let's go to this first Spring project. Okay. And now what we have to do is we have to start setting up our Spring Data JPA altogether. In order to do that, what do you have to do is you have to integrate Spring Data JPA library. So you search for Spring Data JPA, and I'll do this more formally later as well. I'll do this more formally in the next part as well, but I just want to show you a demo. Okay, and you search for Spring Data JPA Gradle. Getting started accessing data with JPA. Okay, so probably here we should get some Gradle definition. Okay, here they have not given. Let's take it from Maven repository. Okay, so we are going to take, you can see Spring Data JPA. That's what we need. Let's take the 3.2.4 version. And you can see this is from Gradle. We can take it. So I guess it copied. And all we will do is we will go to our build.gradle and we will add it. Okay, you can see Spring Data JPA I have added. The moment I add it, it shows me a load Gradle changes. The moment I do it, you can see it says Gradle building. Let's wait for it to do. And now you can see most of the things are up. Most of the things are up. Now what you have to do is you have to connect to a MySQL server. Sometimes you might have to connect to a PGSQL server. Sometimes you might have to connect to something else. So what you have to do for is you have to search for configuration settings to connect MySQL with Spring Data JPA. You will never remember these, guys. You will never remember these. I don't remember these. And you don't need to remember this. Everything is readily available on Google. So you don't need to bang your head in remembering them. And you can see Gemini directly gives us. So what you have to do is you have to add a bunch of configuration. For example, you have to add a configuration Spring Data source.url. This is going to be the URL of the MySQL server and the database you want to connect to. Okay. Then you are going to take a username. You are going to take the password of your MySQL server. You are going to tell the driver class, right? That which driver do we want in order to connect. If it is a MySQL server, you need a MySQL driver. Okay. And then you need one more data platform that, okay, internally, which ORM Spring Data JPA is going to use, because Spring Data JPA is above the layer of ORMs. So it is going to use Hibernate ORM. Can you see? So what I'll do is I'll copy all of this. And where should we paste it? If you go to the resources folder, there was an application.properties. You can see here we have to paste. Here we have to paste all of this. Okay, so you can say that application.properties is the place where you can actually define configurations of your project. Now here, what I'll do is I'll mention my database. So let's go to my database. Yeah. And let's create a brand new database. I'll say create database and let's call it as test JPA. Okay. You can see I have a brand new database, test JPA. I'll take it and I'll mention it here. Okay. So this is my database, you can say URL. Okay. Why it is JDBC? Because it is going to use JDBC connection for connecting to MySQL server. It is going to use the MySQL driver altogether. Okay. And then username of my MySQL server is root only. I'll put my password. I guess it is mac@local12345. Okay. Don't worry. I don't use this password anywhere else apart from my MySQL server because I know I have to use it in classes. Okay. And that's it. That's it. The moment you have this, more or less, it should be good. If you want to check if it is good or not, just try to run your Spring Boot project. If your project goes up and running, you have done the configuration properly. Okay, you can see the project is up. Now, what we have to do is, now we have to define the entity. Okay, currently I'm not creating any folders or anything. Let's do one thing. Let's create a Java class to do. Okay. Okay, let's create a to do class. Okay. Now, inside this to do class, we are going to have some properties. Okay, let's say we are going to have some corresponding properties. Now, what all properties we can keep? Now, to do can be having an ID. Maybe we can have a to do ID. Then we can have a to do task, or maybe to do details, something like that. Can I say that? Right? We can have different to do details, right? Now, ID generally is your primary key. ID generally is what? Your primary key, right? Inside your corresponding databases. Okay. So what you have to do is you have to make sure that you handle each and every individual property in the right way. Okay. So let's do that. Let's do that. Now, first of all, what do you have to do is you have to annotate this class with an annotation called as @entity. Okay. @entity. One second. Let's see. Cannot resolve symbol entity. Let's see. Are we missing something? Spring Boot starter data JPA. Let's see what we have added. Spring data JPA. Oh, we have to add one more library. We have to add one more library. This Spring Boot starter data JPA. We have to add this also. Gradle. Okay, so this is going to give us the certain set of JPA annotations and everything as well. So let's use this version. Gradle short, I'll copy and I'll paste. Okay, Spring Boot starter JPA. I'll just reload my project. Cool. Now, if you will come here and if you will see, you can see the annotation is actually coming up, right? So I can write it again. @entity. Okay. You can see we are getting it from jakarta.persistence.entity. Okay. So you can actually check the difference. So there is something called as Jakarta versus Java X persistence. Okay. You can see Jakarta persistent layer JPL is the successor to the JPA and is the part of the Jakarta EE specification. It is built upon top of JPA and provides similar functionalities for managing relational transactions. Can you see? So it's similar to Java X. Sometimes you will find people actually adding Java X.persistence.entity. Sometimes you will find people actually adding Jakarta.persistence.entity. Right? Things are not going to make much of a difference. Make sense? Okay. Cool. Now, apart from this, what do we need is we need to have some properties. We need to have some properties inside this task. So let's say the properties that I'm going to have is string title. Okay, string title and Boolean completed. Okay, let's say we have these two properties. Now, can you see it is throwing us an error? What is the error? It says entity doesn't have a primary key. Entity doesn't have a primary key. So let's define it. We can have an ID property as well. So you can say integer ID. You can see it still throws an error. Why? Because it doesn't know among all of these columns which one of them is a primary key. So how do you tell it it's a primary key? You can use the @ID annotation. Okay, cool. Now, just by saying ID, what will happen is it will make it the primary key. Now, either you write, like whenever you are going to create the data, either you will give the primary key or primary key can be auto-generated, right? Sometimes you will see that primary keys are auto-generated in your database. How? You add a auto increment. So primary key auto increment MySQL, right? So if you define a primary key, you can actually define it as auto increment. Can I say that? We can also do that. We can actually also do that. So there is an annotation. Why there is a space coming up? @generated value. Why this space is coming up, guys? Okay. @generated value. You can see this annotation is again coming from same persistence layer. And here you can actually define the strategy, that by which strategy you want to generate it. So you can say generation type dot either auto you can do, or sequence you can do, or UUID you can do. UUID will be taking UUID as the integer, right? I'll talk about UUID more in the later set of classes. But for now, I'll take sequence. The moment you do sequence means that it is going to do an auto increment. Okay, cool. And then you want to make sure that this is not null. You want to make sure that this particular, I would say, column is not null. So you can add some column properties. You can say @column, and you can say nullable equals to false. Okay. So these are annotations that has been provided to us. These are annotations that has been provided to us. Okay. Using this annotation, we can actually do our task. Okay. Cool. Let's have it like this. Let's have it like this. So you can see I just have a string title, Boolean completed, and that's it. Let's run our code. Let's run our code and see what happens. If I run the code, you can see it throws us some error. Let's see why. So if you go here, and you can see JDBC driver got some issue. What is the issue that it got? Error creating bean with this particular name and beans factory. Okay. And if you go down, fail to instantiate factory method data source. So what's happening? Now, what happens is, if I close this, now in order to actually create and attach these values correctly, what do you need is, for each of these like properties, you need a getter or a setter for these properties, right? How it will actually access which property is going to be set by which particular value. So either you are going to define your getter setter yourself, or there is a package called as Lombok. What is Lombok? Lombok actually gives you a set of annotations that can do the getter setter part automatically. So all you have to do is Lombok Gradle plugin, and let's go back once again. Here, let's go get it from here. This one. Copy, and we'll go to build.gradle and paste it here. Okay. So what is this going to do? This is going to actually integrate the package Lombok. Again, I'll talk more about Lombok as well later. This is just for demonstration purpose. What Lombok is going to do is, if we install Lombok correctly, then it will give us annotations like @getter, @setter. Those annotations, what they are going to do, they are going to automatically implement getter setter for all the properties. We don't have to care about it. Okay. And if I close this, and if I go here, you can see getter. Can you see there is an annotation @getter and then @setter. Let's try it out now. Let's see if I run the code. Can you see we still have an issue? Can you see we still have an issue? Again, we have an issue, error creating the corresponding bean. Okay, now what's happening? Now the thing is, we have one column here that is defined as the ID. What about the remaining properties? What about the remaining properties? So for the remaining properties also, you can give a column property, that this is also going to be a column, and this is also going to be a corresponding column. Let's try it out now. Let's see. Let's go step by step. Okay. So now we have defined all of them as columns. Okay, it still fills. Now let's see what's happening. Let's see if this is a enable annotation processing. Okay, this is okay. Let's Google it. Let's Google this error. Maybe this is due to some dependency. We'll just go here. Looks like the initial problem is with auto config. If you don't need data source, let's see. No, you don't need to give @table dedicatedly. It's not necessary to give @table. It might be happening because of Jakarta. Let us see what I can find. So what all packages we have? Okay, let's check a few more Google links. Also, this is also giving us some error. Let us see, maybe it's if this is the issue. Maybe you forgot the MySQL JDBC driver. Okay, so that's the interesting part. Now, if you carefully see, we actually added all the packages that were required instead of one. Like we forgot one package. which was the MySQL driver. We have not added the MySQL driver package. Java doesn't has it automatically, right? So you can just get it from here. So MySQL JDBC driver, Gradle. You can see MySQL connector Java. This is coming up. It looks like this is the driver for us. Let's try it out. Okay, let's copy this and paste it here. Let's refresh the Gradle project. Okay, and in the to do, I'm going to, let's say, remove the column properties for now. I initially thought it is coming because of that. Now let's run it. Let's see what happens. Still failing. Same issue. And if I bring them back, okay, it says cannot load the driver com.mysql cj. Okay, so this is the error. I guess the driver that we added is not loading for us. I guess there is some other package for the driver. Let's see. We need MySQL connector Java. Okay, okay. Which version we are at? Let's go to this. MySQL connector Java 5.1.6. Okay, I guess we need a relatively later version. com.mysql.cj.jdbc.driver. com.mysql.cj.jdbc.driver. This is correct. Let's see if we can try with a different version. Let's try with a different version, guys. So MySQL connector J Gradle. Okay, I guess we should get a latest version. Let's get the 8.3.0 version, because I guess my MySQL version is also the latest one. So this might be the reason. So, and you can see it's showing us a warning as well. Okay. So let's remove it. Let's try with J 8.3.0.8.0.3.31. Okay. Let's see. Now we have this installed. This is good. This is good. And you can see, let's see. And let's try it once again. Okay, it's still failing, still failing. Let's see. Okay, I guess what you have to do is, now you don't need to mention this driver separately here. I guess we can comment it out. Okay, so let's comment it out from here. Now let's try it again, because we have now separately added the driver. Once again, what's happening? Creating bean is still getting the issue. Unable to create requested service. JDBC environment unable to resolve name. Okay, okay. Now this is giving an issue. Let's see. I guess this name is also kind of pretty old. I guess we took it from Gemini, right? We took the configurations from Gemini. Maybe that's why it is having a lot of issues. Okay, let's try it out this. Let's change it to. Maybe Gemini gave us a pretty old set of configurations. Still the same issue. Could not load the required classes. Let's see. Okay, let's do one thing. Let's check some docs. I guess Gemini gave us some wrong info. Connect MySQL with Spring Data JPA Spring Boot. Okay, I guess we took it from Gemini, so some wrong info we got. Let's see. So we have a URL good, username, password good. we need a driver class. Let's get the driver class. Okay. Let's get the driver class. Okay. I guess without this DDL also we can do good. We don't need the last one. So I'm removing the last one. What was the last one? This database platform I'm removing. I'm just keeping it like this. Let's try to run it now. Okay. Again, you have to check the documentation. You can't remember everything. And yeah, now it is good. So I believe Gemini gave us a few wrong configurations here and there. And now you can see everything is up and running. The moment everything is up and running, now let's go to our database. So I'll say use test JPA. I'll say show tables. You can see currently we do not have any set of tables. Can you see? If I do show tables, as of now, we do not have any set of tables. Can I say that? Okay, cool. Now for this, there is this configuration called as DDL. What is DDL? DDL means data definition language. That if I'm defining any particular class, do I want Spring to automatically generate a corresponding table for me, or do I want Spring Data JPA to create a table for me? This is something that we can configure. So let's read about this one. See, so this DDL, okay, this property is going to tell that whether we should allow it to automatically update or create our corresponding set of what I should say tables or not, because we have defined corresponding, you can say this thing, to do class, right? Now we need to actually tell what do we want. Do we want Spring Data JPA to automatically create things out of it, or we are going to create the tables? Spring Data JPA should only read things. What do we want here? We have to actually tell it. Okay, we have to actually tell it. Okay, so what we'll do is we'll check the values for it. Okay, so if you go here, you can see you can have value as create, drop, validate, update, a lot of things, right? So let's do one thing. I'll copy this and paste it here. Equals to, let's say, I'll say create. Okay. I'll say I'm giving it the configuration to actually create everything. Now, if I restart my server, you can see everything got connected properly. Okay. Let's see if we are able to create the table now. If we do show tables, can you see it has automatically created a brand new to-do table for us. I didn't go and say create table name to do with a set of properties altogether. And if I describe to do, can you see to do has a ID, which is a primary key, a completed property, and a title. Can I say that? So Spring Data JPA is automatically doing this for us. We do not have to create the table altogether. We can have that privilege with us that, okay, do not create tables for us automatically. We are going to separately create it. You can configure it accordingly, right? You can configure it in one more way. For example, drop table to do, drop table to do sequence. Okay, I'll show you later what is this to do sequence. But what you can do is you can make it go create drop. What will happen with create drop? Let's see. If I restart the server, it is automatically going to go check all the classes which are mentioned as entity, and it will create that table. You can see if I do show tables, can you see tables are back? If I stop the server, okay, let's see now what happens. Show tables. Can you see now there are no tables? Why? Because what does create drop configuration means? Create drop configuration means that we are going to create a brand new table, but the tables will only persist till the time we have the session up. The moment we will close the server, all the tables that it has created will be dropped. Are you guys able to get this point? Okay. And in fact, you can add one more configuration, which is spring.jpa.show SQL is equals to true. If you add this configuration, and you can see all of this I'm doing in application.properties. If you add this configuration and run it, so can you see? It will also show you, if it will also start showing you what is the SQL query it is executing. Can you see? It will also start showing you what is the SQL query it is executing. So if you want to have logs coming up, you can set it as correspondingly true. As simple as that. Make sense, guys? So can you see Spring Data JPA is doing a lot of things for us? If I want table to be inserted with name to do underscore transaction load like this, then so you are saying that you want to update the table name according to your use case of create and drop just for testing purpose. Aditya, you want to specifically give the table name? Are you saying that? So again, I'll of course going to talk about much more details. This is just a demo, guys. All of this we are going to talk about again later because in more detail. But here the entity expects a name property. If you give us some default name like something XYZ, this will be the brand new table name for you. So you can actually configure it accordingly. Okay. Because I have given the configuration create drop. Different configuration will be using different commands. Abhijit. Okay. Now let's see the interesting stuff. Now what I'm going to do is I'm just going to create one last class, new Java class, and let's call it as to do repository. Okay, this is not going to be a class. Instead, this is going to be an interface. And what we'll do is we'll say this interface extends JPA repository. Okay. In this JPA repository, what we are going to do is we are going to say that we are going to map it with to do, and the ID type is what? ID type is integer. So we'll say integer, and that's it. And just to make sure that Spring manages this class, we are going to add a @repository here. Okay, we'll talk about later about around the repository annotation. But now, what you can now actually do is you can actually start using all of these, I would say, functions that are automatically be given to you. Okay, so let's see how to get it. Let's close the server. Now inside hello controller, let's say we are going to have to do repository. Now you can do a constructor dependency injection, but for sake of quickness, I'm doing a auto wired. Okay, and then here, what you can actually do is you can say to do repository dot. Now can you see there are a bunch of methods: delete all by ID, delete all by ID in batch, find all by ID, find by ID, find one. Have we implemented these methods? Did we implement these methods? No. Okay. So if I do to do repository dot find one, or let's say I do find all. Okay, I do find all. What is this going to return? You can actually, and Spring is automatically showing you. So what is this going to return? This is going to give you a list. So you can say a list of to do we are going to get. Okay, and let's import list. Okay, so this is going to give you a list of to-dos. Are you able to get this point? And now it will automatically make a query here and fetch the corresponding list of to-dos for you. And then you can play around with it. Now, you have not implemented this find all. You have not implemented this find all, right? How it is coming up? Spring Data JPA automatically gives it to you. Okay, so if you go to the JPA repository, so let's say go to implementations, right? You can see there are a bunch of implementation. You can start reading about it. You can actually start reading about it. There is a delete function coming up, delete all by ID in batch. You can see there are these generic functions that have been already implemented, and they actually prepare a query string. And then can you see this is an entity manager? If you search for this entity manager, where is this entity manager coming from? Or let's go to the source. Go to declaration. You can see this is the entity manager. And where is this coming from? You can see it's in the Jakarta persistence or the JPA persistence. Make sense? So you can see you do not now have to go to all of those JDBC, Hibernate, all of those levels. Spring Data JPA is going to do everything for you, right? As simple as that. Okay. Now there is a lot of unknowns that you might be facing. What is this to do comma integer? Why only integer? Why not something else? All of this we are going to talk about step by step. Okay. But this was something that I wanted to make sure that you keep in mind, so that whatever we have discussed regarding the database part, it doesn't look just superficial to you. This was kind of like a trailer that what are the powers that Spring Data JPA possess. Now, slowly and steadily, we are going to start talking about more things around it. Make sense, everybody? Any questions? Okay, so Spring Data JPA is powerful. I hope you got the context that what it is, what it can do. Some people who must be already working might have got more context that, okay, what is the step-by-step procedure that internally it is doing. Now, later in the set of classes, this is going to be something that we are going to use in order to integrate database with all of our project. Probably we'll try to actually set up a few things. I can give you a homework that maybe the REST APIs that you were preparing, maybe now try to integrate a database layer to those REST APIs and prepare a repository layer altogether as well, so that you can get a better idea on what's actually going on. Okay, but of course, we are going to also do it step by step. Make sense, everyone? Did you guys enjoy today's lecture? Cool. That being said, let's wrap today's session here, guys. Whatever implementation discussions we did, don't worry, we are going to see each and every configuration, each and every, I would say, step again, so that you know what we are doing. This was just for the trailer part, so that you can understand how exactly things are integrated. That being said, let's wrap today's lecture here. We are going to meet soon in the next set of sessions. Till then, take care, guys. Bye-bye. Have a really lovely week ahead and keep coding, everyone.